before going in depth into the technical and architectural aspects, I would like to say a few words on who we are and what we do. So Lowe is a retail company specializing in home improvement. It is founded as a small store in North Carolina in 1946. And since then, it has grown into one of the largest home improvement retailers in the world. We serve homeowners, renters, and pros and help them to improve their homes and businesses. We strive to provide value and seamless experience across every channel that we serve. And to accomplish that efficiently and effectively, our Lowe's technologies are undergoing a heavy transformation in all key areas, such as like our digital systems or our store systems, our supply chain, pricing, and many other key applications. With this transformation, our main agenda is to deliver value to the evolving customers' expectations in this modern world. So in Lowe's, I'm part of enterprise integration and API management space, where I'm responsible for defining and implementing integration strategy and to deliver the right value. We provide integrations to share data across various channels, such as our e-commerce.com domain or our mobile apps or our stores point of sale and applications, both internal and external to Lowe's. So our main technology goals in both old or this new modern world remain same as high availability, high stability, high resiliency, and high performance. But based on the technology and customer expectation evolutions, we have to revise our strategies in achieving these goals in an effective manner. So our main focus points in defining this new strategy are speed, quality, and scale. To achieve these, we are aligning ourselves to a hybrid cloud strategy. A couple of years back, we used to have just an on-premise infrastructure with 2 data centers, one for production and one for dev test, I think like most of the other companies are. And we had quite a bit of packaged software that we customized so much where it became challenging even for support as well. And it is hard to make large-scale transformations with this kind of setup, as this created isolated platforms with isolated data. And also it requires us to staff separate teams with each different skill sets. So we have now shifted our focus to a digital transformation strategy that relies on building customized solutions to leverage new age of cloud technology and open source technologies, which are way far nimble and most cost effective in providing effective solutions with our major motives, which I said before, which are speed, quality, and scale. As part of this new technology strategy, we move to cloud-enabled technologies, which will improve application availability and scalability while lowering total cost of ownership. With this critical foundation architecture in place, we will be able to offer new functionality to our associates and also our customers and deliver the best-in-class retail experience. In addition to improving our omni-channel architecture to drive better results, we also have started our journey to fundamentally change our technology operating model. So we started this transformation journey for building a truly omni-channel architecture. What does that mean? That means that we need to provide a grounding of a single view of customer orders, irrespective of whether they were placed online or in the store or through the call center or on the job site. It is about creating a single view of customers, products, prices, and inventory. This information will be readily available to all our associates and customers through a flexible architecture deployed closest to the end user for optimal performance. This type of architecture will dramatically improve our major motives, which are speed, scale, and flexibility. And it will also allow us to deploy a bit more frequently, as we will be able to quickly change only the parts that we need without affecting or changing the whole structure of it. We will be able to reuse components, which are literally like Lego blocks, to rapidly construct new capabilities for our associates and customers to embark on a journey of continuous innovation. And to achieve this, we cannot still rely on monolithic way of doing things, right? So we shifted ourselves towards microservices architecture, and we started migrating several of our key applications to cloud-based, such as our digital apps are being deployed in GCP now. And in GCP, we are using different types of offerings, such as we use SaaS offerings, we use infrastructure as a service, we use platform as a service, and different types of things. And like for CRM, we are using SaaS offerings in our Salesforce and in Azure, which is CRM Dynamics. So like this, we have moved several of our other key applications like our customer domain or our selling tools domain, some of these kind of things into GCP already. So main capabilities that we could achieve with this strategy is reduction of lead time from dev to prod, as everything is isolated and no dependency on one another. And it also reduces the developer feedback loop interval. And we could create a portable services which can be deployed across on-prem and cloud for achieving hybrid cloud strategy. So this architecture, along with containerization, makes it truly platform agnostic, which helps to move towards our hybrid cloud strategy. Considering all these technology changes happening at Lowe's and we being part of enterprise integration space, we started to think on what this means to integration capability. Integration technology that we are using or used to use is based on the concept of using a central integration bus or enterprise service bus, which is ESB, as many of you already know of. This kind of softwares can connect to various types of apps and package products seamlessly. But the question is, can this still continue in this modern way of doing things? With the drastic change in the enterprise integration and API requirements, fine-grained services, IoT, etc., most conventional integration solutions are falling apart when it comes to realization of those new integration use cases. But does this mean do we need to completely avoid integration and simply move the routing or encapsulation logic that used to reside at the central ESB to end application microservices and treat communication channel just act as like dumb channel to go with the convention smart endpoints and dumb pipes? So when we thought about that kind of implementation, it's very likely that we will end up in having point-to-point connectivity between producers and consumers. Unfortunately, this is the same point-to-point mess that ESB is originally designed to solve. And this will become even more worse with microservices architecture, as we will experience a drastic growth of the number of services that we need to integrate with. And maybe this type of implementation very well works with newly built modern applications where they can support all modern ways of doing things with either external and internal applications. But Lowe's has many proprietary legacy systems like many other businesses, to which it would be very hard to integrate this modern way to other apps. But definitely integrating with same old central integration bus cannot be survived in this hybrid cloud model. So we thought that we definitely need an integration strategy to be on par with our overall Lowe's technology transformation, which means we should be able to provide agile integration, microservices enabled integration, and we should be able to deploy containerized apps into cloud or on-prem to achieve our hybrid cloud model. So to achieve these capabilities, we started researching on open source technologies and tools to satisfy shown key drivers, such as providing integration as microservices, which can be portable and scalable, and we should be able to achieve build once, deploy anywhere, which is nothing but provide cloud native hybrid integration. And they should be like individual Lego blocks, like how I told before, where we could perform increment and frequent rollouts without any dependency between one another. So we started researching on available open source integration frameworks, and Apache Camel Spring integration and Mule ESB are some of them. We have done some POCs with all these frameworks and decided on Apache Camel because this framework has wide range EIPs already available where we could plug and play rather than writing so much of boilerplate code. And it also has many connectors that it natively supports. Then we started looking for a product which supports Apache Camel and satisfy our last key driver, which is flexible licensing model and lower total cost of ownership. So we found that Talend supports Apache Camel, and as an added advantage, it could provide Spring Boot jars or Docker containers out of the box, which means we just need to write the code and it will be all well packaged with Spring Boot or Docker if needed, which gives us a ready to deploy app in our desired platform, whether it is on-prem or cloud. And also more to that, Talend created wrappers on top of native Camel components to make them available as GUI-based Camel components, where developers for most part of it could just drag and drop into their Camel route canvas and could set appropriate configurations for each of them as per requirement. And Talend also has rich data mapper functionalities as part of their data integration offerings, which could be interlinked to app integration Camel routes as well. So with that, or using Camel mapping functionality, which is called CMap, mapping could be done like any other proprietary ESB mappers for most part of simple to medium complexity mappings. Only place where we have to embed some Java code is for transformations for like complex legacy structures like EDI structures or so on and so forth. But otherwise the normal data mapping functionality that Talend provided is helpful for us. So by now we figured out our integration framework and products that supports it. So now it's time for transformation. But the question is where we start with. This is how we achieved it. We picked some low business critical services where we could achieve better ROI by being able to reduce the licensing costs of existing integration product and also decrease the infrastructure footprint, as with this implementation, we would not need so much of infra to be sitting stagnant as the solution is scalable based on real need basis. And one more area we looked into is considering integrations with different patterns and protocols so that we could deal with any issues in terms of development or deployment for specific pattern with these low business critical services, as impact would be less. And once we could cover all different patterns and protocols, we will be confident when dealing with high business critical services. And while doing this exercise, we have created templates for each design pattern and respective source and target protocol. And we also developed common frameworks like auth handling, which is like OAuth handling or logging or exception handling, etc. So that developers can use them and create a code skeleton. And from then all they need to do is just mapping specific to business requirement. This saves a lot of time in development and also provides consistency across different camel routes, which makes issue triaging also easier and faster. With Talend, we could refer these internally built templates or frameworks as reference projects connecting to a code repository. Every developer could connect to their actual project in their local studio for development and still refer these templates and frameworks as reference projects. Using these technologies and products, we are able to modernize ourselves from traditional ESB architecture to a hybrid cloud-native integration architecture. Four major areas in this architecture are integration and data services, which are built in Talend, event messaging, for which we use Kafka, API management, for which we use Apigee Hybrid, and Lowe's built-in DevOps framework, which is referred as Carbon here. Talend got baked into this architecture so seamlessly as it could provide containerized integration apps out of the box. And it also provides CI builder, which can be configured and used along with Jenkins to create either Spring Boot jars or Docker containers via automated Jenkins build process. These Docker containers can be easily plugged into our common DevOps framework to create Kubernetes and Istio-based workloads and deploy in either GKE, which is Google Kubernetes Engine on GCP, or on-prem Kubernetes products. And we are extending this framework to our stores Kubernetes solution as well. So this architecture suffices all the key drivers that we discussed before, as here we are able to create containerized integration apps, which are portable across different vendors. And if you see, we segregated them based on product or domain by creating different namespaces for better maintainability and orchestration. Overall, this helped us to deliver our functionality in truly agile fashion and still adhere to native CI/CD process, which is one of the other key drivers that we have. And with this, we are building applications which could be scaled up or down as per demand, so that we need not have the full capacity of infrastructure at all times that I have mentioned before. Like in the current state, as David mentioned before, for most part of the year, we just use 10% of overall capacity other than our peak sale days. So we talked about our overall reference architecture. Now let's deep dive into the actual integration microservices architecture that we are focusing on to achieve the integration capabilities. So we follow multi-layered integration microservices architecture where different types of services will be provided with the combination of these technologies mentioned. First one is core or atomic services are created mainly for legacy systems where they cannot directly connect to latest transport mechanisms. And for those, we provide an enterprise service or an enterprise API. And these atomic microservices, either created by us or directly by the application teams, cannot be directly mapped to a business functionality, as most of the times they are too fine-grained. Specific business functionality may require a composition of multiple atomic or core services. So this is the capability we provide, which are composite or integration microservices with capabilities such as routing, transformations, orchestration, resiliency, stability patterns, etc. So composite or integration microservices are coarse-grained services which are independent from each other and contains logic on what services to call and how to orchestrate and how to do data mapping, etc. And they should also deal with network communication logic like inter-service communication through various protocols, OAuth, resiliency behavior, fault tolerance, etc. For these kind of capabilities, we use other technologies mentioned here, such as we use Istio service mesh for internal mesh-to-mesh communication and API management for external communication. Next layer is API edge services, which are either composite services or even some atomic services exposed as managed APIs via API management layer. These provide capabilities such as versioning of APIs, API security patterns, throttling, monetization, fault tolerance, etc. that I have mentioned before as well. And sometimes these also can apply some basic routing capabilities. So we use APG hybrid to be for building these API or edge services. In these layers, we use Talend mostly to create atomic and composition layers, as Talend majorly provides all mediation and transport specific components out of the box, which are based off Apache Camel. It has components for each and every Camel EIPs, and for majority of industry-wide transport protocols such as SOAP or REST or connecting to databases or connecting to any other messaging systems like MQ or Kafka, etc. So these can be drag and drop to the Camel routes, which saves a lot of development efforts. This architecture also gives us flexibility implementing different types of patterns, being it synchronous or asynchronous, between applications residing in different clouds or on-prem topology. We achieved that by integrating Talend along with APG Hybrid and Kafka. All synchronous traffic can be routed to Talend either via APG if it's external, or if it's internal within the mesh, then via Istio proxies. So in that way, we could isolate certain security, throttling, and other network protocol related features aspect of these layers. And any async traffic will be reached to Talend via Kafka from GCP or on-prem and send it to any other cloud apps back or on-prem apps back. We achieved this by using Kafka replication and producing or consuming to the nearest Kafka broker. Talend seamlessly connect to Kafka either as a producer or consumer with its Camel Kafka component, where otherwise we would need to write whole Java producer or a consumer code in every app. Either we can implement a pub/sub type of solution within Talend app itself, or we can just produce to Kafka and end application can directly connect to Kafka and consume the data and use it for their own processing. But our end goal is to make this architecture as flexible as much so that it will be not like conventional ESP products or traditional SOA. And I think we achieved that with the reference architecture that I showed below, that I showed before, and also this microservice architecture. If we could just sum up all the facts that we discussed until now, Talend definitely hit a lot of checkboxes for the mentioned key drivers to build this integration modern strategy. Mainly, it could deliver the most important aspect, which is cloud native or build once deploy anywhere integration apps, which along with its built-in components, it definitely fast-paced our development. And with their build process synchrony with CI/CD tools such as Jenkins or Spinnaker, and ability to create readily deployable Spring Boot jars or Docker containers, it very well helped us to automate our deployments as well. And when we are trying to choose a product who can support in our journey, one of the main consideration is flexible licensing model, which is support and utility based model rather than core usage model. And Talend perfectly worked out for us there also. So we started this journey from August 2019. And since then, we are able to integrate and share data among different key Lowe's applications, such as our customer application, our digital systems, our supply chain tools, our order management systems, our CRM systems, our customer communications, or vendor apps like this. There are many other applications which we integrated with. And apart from that, we could as seamlessly integrate with legacy apps as well, like our mainframes or DB2s or such kind of legacy systems. So that is a great success for us. And we deployed almost close to 100 integration microservices in this span of a year. And this is achievable as Talend seamlessly integrates with our other Lowe's built-in frameworks rather than reinventing the wheel or doing it differently. This also created consistency for our integration microservices to be similar to any other business app services in terms of deployment or infra requirements. That is also a major achievement for us. With flexibility in licensing model and providing apps with scaling capability, we will be able to cut down operational cost to vast majority in non-peak days. Finally, I would like to share some of the experiences that we had gone through in order to make this journey fruitful. So first, like everybody else, we also had questions when we started this transition on moving to completely microservices. So we thought of, can we use OSGI kind of implementation where we could group some of the services and deploy into a product container like Apache Karaf. And by the way, that is the supported Talend ESB engine as well. So I usually don't like the answer, it depends. But for this question, it truly depends, as either option is not wrong. Think about how your organization is changing and what are the key factors you want to bake in into making this decision. Like for us, the key is to make it truly cloud native and to leverage our commonly built Lowe's frameworks like our OAuth framework or DevOps framework, etc. And the other main key is flexibility. As in our overall transformation journey, many Lowe's applications are getting migrated into cloud from on-prem or sometimes vice versa. So as an integration provider, we don't want to bundle them in any way that will again be hard to isolate. So in a similar way, you can think about key drivers for your organization and take a decision. Secondly, as I mentioned before, it is always better to create abstraction and composition layers, as otherwise, when backend system changes, all the apps that are connected to it has to make the change rather than at one single place. And when we could achieve that composition or abstraction with all the necessary traits like microservices or containerization or cloud native, etc., it would be as seamless and flexible like any other app, right? So think of it in your organization and try to analyze on how much impact it would create when some of these backend applications changes, and then you can come to a conclusion. Lastly, in this world, whatever transition or modernization that we are planning to do, we have to do it in an accelerated manner. As things are changing day by day drastically, we could not afford same amount of time that we used to take before to analyze, to plan, to design, and then develop, and then rolling out. So we have to implement these features as fast as possible. So some of the activities that helped us is creating templates with which development became way more faster and we can show faster results. Now we could deploy new integration features within a sprint time, covering from the initial requirement phase to testing to go live. So that's a huge win for us. And we also came up with a common dev practice which works for all clouds or on-prem, just with some configuration changes. So even after development and testing is done, in one cloud, we could move that to a different cloud or on-prem with just configuration changes. And as I mentioned, we are utilizing lots of Lowe's built-in frameworks rather than reinventing the wheel again, which saved us a lot of prep work before we started building this integration microservices. And also we don't need to own their maintenance as well. So that's an added advantage. So this is our journey at Lowe's. Hope you all got some inputs out of it. Thank you all again.